All right, next recap is of linear momentum. We went over this a little bit, and it's pretty simple. Linear momentum is represented P equals m times v, mass times velocity. It's representing the tendency for an object to continue moving at whatever speed it's going at with whatever mass. And the biggest idea is that momentum is conserved, meaning this product is the same as before and after. So the main idea is just m1 v1 equals m2 v2. This is true unless we are exerting external force into the system or adding some external sort of energy or force into the system, in which case it's not conserved. But in these cases, it is conserved whether there is no external force. So that's all we really need to know going into problem number 9. Question 9. All right, so there's a particle A here and particle B over here. B is currently at rest. A is currently has a velocity in this direction of v naught. And the first question asks, they tell you at a given time, particle A is only moving at 2/3 its original speed, and they ask you what direction and what magnitude is the acceleration of part B after part A basically slows down. And so we know that there's no external forces. It doesn't tell you any external forces are being put in here. So we can basically assume that momentum is conserved, meaning that m1 v1 equals m2 v2 of the entire system. And in the beginning at time 1, we have no momentum at all from particle B, and basically all the momentum is in particle A. So the total momentum at the beginning is just they have the same mass, so we can just use m times v naught is the momentum at the beginning, and then at time t, we know that particle A has momentum m times 2/3 v naught. So then we have to calculate what momentum B will have, or what speed B will have, and since the total thing has to add up to mv naught, we can see that this must be m times 1/3 v naught in order for the momentum to add up for B. And we can conclude that B will have a velocity of 1/3 v naught. And as for the direction, we know that momentum, the momentum vector has to also be the same. And in the beginning, it's like straight to the left, a good amount, like this far, in v naught, and then at time t1, A is only 2/3, so it's going to be like smaller. And in order for the two vectors to add up to the previous one, B must be going in this way in order for it to add up to the original one. If it was going in the opposite direction, then the original vectors won't add up, so therefore it has to be traveling to the left, and the speed is 1/3 of v naught, so the answer is B.